I want you to try and picture a very specific moment. Imagine a massive construction site. You've got cranes, dust swirling, maybe 1,000 workers in hard hats. It's chaos, but it's organized chaos. Now fast forward to the very end. The dust settles, the building's done, and the project manager walks out, looks at the final budget, and turns to the team and says, "Hey everyone, great news, we have all this money left over. What should we do with it?"
It's a lovely image. I mean, very heartwarming. Sounds like the end of a feel-good movie.
And it's completely fake, right?
Oh, absolutely. According to the data we're looking at today, that scenario is, well, it's basically a fairy tale.
Right up there with dragons and unicorns.
For, having a zero inbox email account just doesn't happen.
So we're diving into a really fascinating collaboration today between AI&GB Consulting and a veteran senior cost engineer, a guy named Juan D. And when they asked him about this exact scenario about projects coming in under budget, Juan didn't just say it was rare, he said the answer is never.
It's a pretty stark reality check to start our deep dive. Juan points out that in 99.99% of cases, the question isn't, what do we do with the surplus? It's always, why did the cost increase so much?
Which really sets the stage for today. We're looking at cost estimating for civil engineering projects. And I know, hold on, I can almost feel your hand hovering over the skip button. Cost estimating sounds incredibly dry. It sounds like spreadsheets and calculators.
I get that reaction. It sounds like accounting. But the sources we have today argue that this isn't really about math. It's actually about fortune-telling.
Fortune-telling. That's a bold claim for an engineering topic.
Effectively, yeah. It's about predicting the future in a really chaotic, messy environment. It's about managing invisible risks and, reading between the lines of a blueprint before a single shovel even hits the dirt.
So a cost estimate is like a roadmap of a future that hasn't happened yet.
A future that is actively trying to bankrupt you.
Okay, that's a much more dramatic way to frame it. And the core argument from this draft blog post makes a really surprising point right off the bat. It argues that estimates don't fail because the engineers are bad at math.
Which is the common assumption, right? When a project goes over budget, you just think, oh, they miscalculated, forgot to carry the one.
Right. But these are people who took a lot of calculus. The math is the easy part.
Exactly. I mean, ask an engineer to calculate the volume of concrete for a foundation. They can give you a number with extreme precision. The math is perfect.
So if the math is perfect, why is the budget so often wrong?
The force argues that the failure happens before the first calculation is even made. The failure is in seeing the context.
So today, our mission is to uncover what the source calls the invisible scope. We're going to look at the factors that don't show up on drawings, but drive the price tag way up. We'll talk about why contingency isn't just a slush fund and how time literally destroys money.
And we'll finish with a really cynical but pretty hilarious insight on what happens on that 1 in a million chance a project does have money left over.
Okay, let's start with this concept of the invisible scope. The source material uses a classic visual here. The iceberg.
It's a classic for a reason. In this context, the tip of the iceberg, the part you can see, that's the drawings and the specifications, they tell you what to build. A wall here, a pipe there.
And that's what most people think an estimate is based on. You just measure the wall, price the bricks, and you're done.
If only it were that simple. The dangerous part is, it's all underwater. The massive part of the iceberg is the context. The drawings tell you what to build, but they almost never tell you the constraints of how you have to build it. And that is where the money is lost.
Let's get into the examples from the drafts, because I think this is where the fortune-telling part really comes in. The first one is logistics and access.
Right. Let's do a quick thought experiment. Imagine two identical projects. Same design, same materials. Project A is in the middle of an open field. You've got a massive staging area. Trucks can come and go 24/7.
Okay, that sounds like easy mode, total freedom.
Relatively, yeah.
Yeah.
Now, take that exact same design project B and drop it right next to a school in a dense city center.
Immediately, I'm thinking about traffic.
Exactly. But it's not just traffic is bad, it's specific restrictions. Maybe you can only bring in concrete trucks between, say, 9 a.m. and 2 p.m. to avoid the school rush. Or maybe there are noise ordinances, so no heavy machinery before 8 a.m.
So even though the wall is the same size, your window to actually build it just got way smaller.
Drastically. Suddenly your labor duration doubles. You're paying a crew for a full day, but they might only be effectively working for half of it. That restriction isn't on the blueprint, but the cost of the wall just skyrocketed.
That makes perfect sense. The what hasn't changed, but the how just got really expensive. The source also mentions environmental constraints, like weather.
Oh, yeah. Juan mentions the rainy season. It sounds so obvious. But if you schedule major earthworks like digging foundations during a region's rainy season, you are just asking for trouble.
Because mud is harder to dig. Or is it just a pain for the workers?
It's not just a pain, it can be physically impossible.
Yeah.
Heavy machinery sinks. Trucks get stuck. You spend half your time pumping water out of the site before you can even start. A 2-week job becomes a 2-month job. If the estimator didn't look at a calendar, the estimate is basically worthless.
It's not just rain, though. The source brings up the supply chain. This feels very relevant right now. But can't you just check the price of steel on the market and plug that in?
You can check the price, sure, but can you check the availability? The source highlights what's called lead time.
Okay, define that for us. This is context.
Lead time is the gap between I ordered it and it's actually here on site. So let's say you need specialized switchgear or specific steel beams. You might budget the cost of that steel perfectly, but if it has a 12-month lead time, you have a massive problem.
Because you're just sitting there waiting.
And you aren't just waiting for free. That delay might push the installation into a new fiscal year, which messes up funding. It could mean you have expensive cranes sitting idle on site.
Renting by the day.
Exactly. Waiting for something to lift. If you didn't see that 12-month wait coming, your whole schedule and your budget is broken.
There's another invisible factor here that I found really interesting. The idea of a nearby mega project.
This is a huge risk that almost no one outside the industry thinks about. Let's say you're building a small bridge. Standard job. But 10 miles away, they start building a massive hydroelectric dam or a new pro sports stadium.
And that mega project needs workers.
It needs all the workers. It acts like a giant vacuum cleaner for the local skilled workforce, welders, operators, electricians. They all go to the big job because it's steady work for years with better pay.
So where does that leave your little bridge project?
Desperate. To get anyone to show up, you now have to pay premium rates. You're in a bidding war for labor. If the estimator didn't look at a regional map, they miss that cost completely.
And then, of course, global disruptions. Pandemics.
Right. That changes the how significantly. It alters your standard procedures. If health protocols say you can only have 5 workers in a space instead of 10, your productivity just got cut in half. Things take longer. And that is a huge hidden cost.
So the key takeaway here is pretty blunt. Context is expensive.
Precisely. If an estimator is just counting bricks and not asking about site access or seasonal rain or what's being built next door, the estimate is incomplete. It's fiction.
Okay, so we know there are all these invisible risks. How do you plan for them?
Yeah.
This brings us to contingency. And I have to be honest, in my head, contingency just sounds like the oops fund.
And that is exactly the misconception the source tries to dismantle. You're describing how the private sector often treats it. As a slush fund, people just tack on a flat 5% or 10% and say, this is in case we forgot something. It's lazy.
But isn't that better than nothing?
Better than nothing, sure. But in high-stakes infrastructure, contingency is a formal risk management tool. It isn't a guess. It's a calculated buffer. They know something will go wrong. They just don't know exactly what.
The source mentions something called a risk register. That sounds very official, like a book of doom.
It basically is. A risk register is where the team sits down and identifies specific uncertainties. What if we find bad soil? What if fuel prices spike?
And they don't just list them, they put a price tag on each one.
Exactly. They assign a probability and a cost. So they might say, there's a 20% chance we hit bedrock, and if we do, it costs $100,000 to blast. You do the math. 20% of $100,000 is $20,000. That goes into the contingency bucket. It moves it from a feeling to a calculation.
And there are actual guidelines for this. The source lists a sliding scale.
Yes, it depends on how much you don't know. For new construction, the guideline is typically around 5%.
That seems really low.
Well, think about it. You're starting with a blank slate. You have soil reports. You aren't fighting an existing building. The conditions are more predictable. But compare that to a renovation. The source suggests 10% to 15% for that.
Right, because you have no idea what's behind the walls.
Exactly, or what's underground. You tear down a wall and find asbestos or structural rot or pipes that aren't on any of the drawings. The unknowns are way higher.
And for an early concept design, it's even higher.
20 to 30%. Because at that stage, the scope isn't even fully defined. You're basically guessing at the shape of the building.
That makes sense. Now, there was an expert tip in there that I thought was great. It was about where you put this money. It says, do not hide contingency in unit prices.
This is so crucial for transparency. Sometimes estimators will try to be safe, By padding the cost of, say, the concrete. They'll think, concrete is usually $100 a yard, let's put $110 just in case.
They're hiding the buffer so the client doesn't see a big contingency line item.
Right, but Juan says that's a huge mistake. Keep contingency as its own separate visible line.
Why does that matter? If the total number is the same, who cares?
The project manager cares a lot. They need to see their risk budget. They need to track when it's being used. If it's hidden in the price of concrete, you have no idea if you're actually over budget or just eating into your buffer. You can't manage a crisis if you can't see it.
Got it. So transparency is key. Don't hide the safety net. Okay, let's move on to the relationship between time and cost. The source has a great quote here. A project estimated in $2025 cannot be billed in 2027 for the same price.
This brings in the concept of escalation, and this isn't just about regular inflation. It's the provision for cost increases over the life of the project market changes, labor rate hikes, material costs.
But it's not just that things get more expensive over time, right? It's about the schedule itself. The source talks about the cost-loaded CPM schedule. Can you break that down? What's CPM?
CPM is the critical path method. So imagine a giant web of all the tasks on a project. Some tasks can happen whenever, but some tasks must happen in a specific order. You can't put the roof on until the walls are up. You can't put the walls up until the foundation is poured.
That sequence: foundation, walls, roof, that's the critical path?
Correct. The critical path is the sequence of tasks that determines the project's absolute earliest finish date. If a task on that path is delayed by 1 day, the entire project is delayed by 1 day.
And why does that specifically kill the budget? If work stops for a week, don't you also stop spending money for a week?
No, and that's the trap. You might stop spending on materials, but you don't stop spending on overhead. Even if construction stops, say you're waiting 6 months for a permit, the meter is still running.
What meter?
The management staff's salaries, the site trailer rental, the security guards, the insurance premiums. You are burning cash every single day that project exists, whether work is happening or not.
So a delay isn't just we finish later, it's we pay more to finish later.
Exactly. A delay on the critical path literally burns money. Plus, in that 6-month delay, the price of steel might have gone up 4%. Your purchasing power is gone.
So time equals money isn't just a saying. It's a mathematical formula on these projects.
It absolutely is. You cannot separate schedule from cost. They're two sides of the same coin.
Okay, we've talked about invisible scope, risk money, and time money. Now let's talk about the human element. Section 4 is about communication. The source argues the most effective tool isn't software, it's just a conversation.
It's the power of asking why.
And there's a great example in the notes about a retaining wall.
Yes. So a spreadsheet can tell you a retaining wall costs $50,000. It's just math. But a good cost engineer doesn't just price it. They walk over to the designer's desk and ask, hey, why are we building this wall?
And what kind of answers might you get?
Well, the answer changes everything. Is the wall holding up a building?
Yeah.
If so, okay, you need expensive reinforced concrete. But what if the designer says, no, it's just an acoustic barrier to block highway noise?
If it's just for noise, you probably don't need a $50,000 concrete wall.
Probably not. If you understand the intent, you can offer solutions. This is called value engineering. Maybe a precast wall is cheaper. Or maybe, and this is the genius part, you can just change the grading of the land.
Like just move some dirt around to create a little hill.
Exactly. Build a berm. Dirt is cheap. Concrete is expensive. You can eliminate the wall entirely. But you can only suggest that if you talk to people and understand the goal.
That is such a good point. The spreadsheet doesn't know the intent, only people do.
Precisely. If you don't ask why, you're just an accountant. If you do, you're a strategist.
I want to circle back to the email exchange that started this whole thing. Armelle Malcomb from the consulting firm emails Juan, the veteran engineer, and she asks him a question that leads to this very funny, very cynical exchange.
She asks if they should include a section on the dangers of overestimating, warning people about budgeting too much money.
Which sounds like a reasonable question. If underestimating is bad, shouldn't overestimating be bad too?
Ideally, sure. But Juan's response is just priceless. He says, in my experience, no project to my knowledge has ever been overestimated. No one has ever said at the end of a project, we have all this money left over. What should we do with it?
It brings us right back to our intro, the fairy tale scenario.
Right. He says in 99.99% of cases, the money is gone. The question is always, why did it cost so much?
But then he adds this little nugget about the 1 in a million chance that there are surplus funds. What happens then?
This is where his experience really shows. He says that even if there is extra money, management's creativity will have no trouble finding ways to spend it.
Either hand out the bonuses or invest in a nice painting.
It's a cynical joke, but it reveals a deep truth about how organizations work. Resources tend to get consumed. If the money is visible in the budget, someone will find a use for it. It's almost a law of project management physics.
It really is. It's like Parkinson's law: work expands to fill the time available. Apparently, expenses expand to fill the budget available.
It highlights why overestimating isn't a real-world problem. The system is just designed to use whatever it's given. A surplus is a vacuum waiting to be filled.
So let's bring this all together. What are the big takeaways for our listener?
I think we've learned that a cost estimate is not just a price tag, it's a roadmap. To do it right, you need to, first, prioritize scope, especially that invisible scope, the logistics, the weather, the labor market.
Don't just look at the blueprint, look at the world around the blueprint.
Second, treat contingency as a calculated risk, not a lazy slush fund. Use that risk register. Be specific about what could go wrong.
And third,
monitor the critical path. Understand that time is money and delays are budget killers. And maybe most importantly, always ask why. Understand the intent so you can solve problems, not just price them.
You know, as we wrap up, I'm thinking about how this all applies to our everyday lives. We all have personal projects, renovating a kitchen, planning a trip, or even just managing our schedule for the week.
We absolutely do. And we usually make the same mistakes. We underestimate the invisible scope. We look at a task and think, that takes an hour. But we forget the travel time, the prep time, the cleanup time.
We don't account for the logistics of our own lives. And we almost never build in a contingency.
Right. If you plan your day down to the minute with zero buffer, one unexpected phone call can destroy your whole schedule. We're surprisingly bad cost engineers of our own time.
And just like Juan said, how often do we end the week saying, wow, I have all this extra time. What should I do with that?
Never. That never happens. The time always gets filled.
So here's a thought I want to leave you with based on that surplus funds anecdote. If overestimation is effectively impossible in complex systems because available resources are always consumed, what does that say about how we should plan our own lives?
It's a provocative question.
Should we maybe stop hoping for leftover time or money at the end of the month? If we know those resources will just disappear into our own invisible scope anyway, maybe we should stop planning for the best-case scenario and start focusing entirely on managing the inevitable creep. Because if a veteran engineer says the surplus never exists, maybe we should just stop waiting for it.
It's definitely something to think about the next time you write a to-do list.
Thanks for listening to this deep dive into the hidden costs of building the future. We'll see you next time.